Expand 1 plus x squared over the square root of 1 plus 4x in ascending powers of x up to and including the term in x cubed. State the centre values of x for which this expansion is valid. So here's the question then, let's have a look at it. So part 1, here, what have we got? We've got 1 plus x squared. And then we can bring this square root up to the top. It's 1 plus 4x. Instead of half underneath, it's minus a half on top. So that's equal to 1 plus x squared then. Now we'll use the binomial theorem. 1 plus nx, so it's minus a half, is the n, times the 4x, which is the x, so to speak. Nx plus n minus 1, x squared over 2 factorial plus, we need one more term, don't we? n minus 1, n minus 2, x cubed over 3 factorial plus dot dot dot. So that equals then, whereas the 1 plus x squared here times, okay, so what have we got? We've got 1, minus times a plus is a minus, 4 over 2 is 2, so that's 2x, minus times minus is a plus. Now we've got a 2 here, we've got a 2 here, we've got a 3 on top, but there's a 4 squared here, so a 2, 2 and a 2, 4 squared is 16 over 8 is 2. So we've got 3 2's here, haven't we? So it's 6x squareds. Now this one we've got 1, 2, 3 minuses, so it's a minus. We've got 4 cubed, so we can take one of the 4's out, and we can take another 4 out. And that was 4 squared that goes out, so it's just left with the 4 on top. There's a 3 here, which can cancel with the 3 there, because it was 3 factorial originally, wasn't it? So what have we got left then? Well, we've clearly got just a 4 and a 5 is 20. X cubed, close brace. So that's equal to then, well, one of these, let's expand it one of these, and then x squared of these. So we've got one of these. So this would be 1 minus 2x plus 6x squared minus 20x cubed. And then we run the x squared through, plus x squared minus 2x cubed. Then plus all the other higher powers, of course, which we don't need to worry about, so it's x squared, minus 2x cubed, and then the rest are higher powers after that. So we end up with then, we've got 1 minus 2x, minus 2x, 6x squared here, and another x squared there, that's 7x squared, minus 20x cubed, minus another 2 is minus 22x cubed. So there's the series expansion then. The range of validity, well, if we look at that, this is the 4x here. The modulus of 4x must be less than 1. So 4x must be less than 1. This is part 2. So that tells us that x times 4 times modulus x then is less than 1. And that tells us, if we put it over here, that modulus x is less than a quarter, so x can go up to 1/4 and down to minus 1/4, so x lies between, because the 4 can come underneath. So I'm going to actually put that on that line there, move the 4 from times to divide from this here.